Hello, welcome. I'm Bill Wake. We're here working on an old BASIC program from the early 1980s. We're trying to convert it from the horrible BASIC go to this, go to there, if then 300 kind of stuff into modern structured Swift, and then we'll work on some improvements after that. All right, let's go over to the code base. Okay, so the core of this thing is in this class blocked. We got our test running in the background. That should be fine. Make this a little bigger. Okay. What we've been doing is, well, last time we focused on places we used to have case like fall through case 15, but nobody jumped to line 15, so we could just fall through directly, and we've been doing that. And also, I think I'm on a mission. If the code obviously matches the basic, or we've totally changed it so that it's completely irrelevant, let's get rid of the basic. So there's nothing that comment is adding. Likewise, this one. So we're getting our front of our thing. Okay, 1 to 25 print. I think that's pretty clear. Go sub 305. Yeah, we'll leave that for a moment. Okay, but you can see where we have go sub. We have to be careful because there's a return value. For line 40, we can't just remove the break statement there. Not yet, anyway. We'll work on it. Okay, and then we also we added this constant move paddle so we can talk about going to this line. Seems reasonable enough. Let me let's take out some more comments. I guess we're officially starting. We're not just looking. Okay, 1 to SC next. That's really just a delay loop. Go to 40. I think that's clear enough. Okay. Well, we did this one pretty well. Move paddle. Yeah, so look, move paddle, it's just, it's got some if statements, but there's no go-tos or any of that stuff. The only thing that's funny is down here at the return statement. But that thing is pretty good shape. Okay, this one less so. 205 poke 32 xb plus b. I think that's clear enough. If peak x equals 32, then b equals x. Go to 225. Otherwise, go to 215. Okay. V equals minus V. That's okay. Poke X and fall through. I think that's all right. B plus H. If peak Y equals 32, then B equals Y. Go to 245. Otherwise, fall through to 235. Okay. H equal minus H, that's fine. I think that's okay. Now, somebody must be jumping to 245. Yeah, there it is. Okay. Go to or return. All right. In case 305, that's pretty clear. XY 128, I think that's all right. For 1 to 23, poke twice. That's okay. That's okay. Y equals 0 to 6, 1 to 22, poke 161. That's all right. All right. And then this one. So what I see here is 305. This is totally end-to-end. There's no go-tos into it or out of it. Only thing happening is the return. All right, so let's run tests. We've done some cleanup. It's pretty minor. So while that's running, we'll look at this code 305. So I don't know if you recall or if you were here. This code is it's called once at the beginning of the game to set it up, and basically it's drawing a line across the top, then two side bars, side walls, and it's putting a bunch of 161s, which are squares. So it's drawing a few rows of squares in there. All right. This constant, horrible as it is, it's the starting point for the squares. The screen's memory mapped, and 53381's the top left corner, and this is down a few rows where you're going to draw the blocks in. All right, let's run it once just to frame where we're going in case anybody's new this time. Are we running? Almost. Okay, we'll click go, and it says hello, and then it starts drawing the top and side walls. Draws a bunch of blocks. Can't remember if there's 6 or 7 rows. 5, 6, 7. And the paddle and the ball. And we can start moving and see if I can estimate this. Maybe one more. Okay. All right. 153 points. Not amazing. Okay. So that's good. And what I want to do now is I've got this block of code from here to here. It's straight line code. I can make a method out of it. So let's do that. We'll do a refactor, extract method, and I think this is like draw initial screen. Oh, do I have to stop? Okay. Draw initial screen. Okay, let's stop. And let's see, put it up top. I always like it on the bottom, but for whatever reason. And let's do a reformat. Okay, are my keystrokes on? Yeah. Okay. So draw initial screen. Now, if we look for 305, whoops. 305. We see go sub 305. There's only 3 matches. That's the implementation of the go sub, which I think that's redundant anyway. Go sub 305, return to 40, 305. So the only references to this block are here, so we can move this block up and eventually inline it. All right, so let's find our 305s. Where's go sub 305? Okay. And we'll put it here for the moment. All right, now what I see is I've got basic go sub 305, return to 40, draw initial screen, return, which transmits me to 40. So I'm going to replace that. And it would be go to 40. And maybe we should do that. Oh, here's another one. Go to 40. It is a target. Well, in our case, we can use the fall through. Okay, so we can look at this code. Oops. Look at this code from line 10 up through here, this is the entry point for the program, and nothing loops or anything like that. So this one can be a fall through. And we don't want to fall through to 305. That's gone. We inlined that. So it's like that. Okay, so whatever, the end of line 10, the current line 10, falls through to 40, or we've got a loop that's a go to 40. Okay, and that's that one. Okay, again, I just kick off tests, and we've extracted initial screen into a method and called it. Yeah, I think that's a good way to describe it. Launching our tests. All right. And we'll peek ahead. Go sub. Okay, this 110. I think that's all right. We know what it means. This goes sub 205, same thing. Okay. And we got 110, which is move paddle or move ball. Okay, let's go down to move paddle. See if we're in the same boat there. I think we are. We've got straight line code. It's got some ifs, so it does have some branching, but there are no go-tos in or out of the whole block. Okay, and so I can extract this method, and I even know what to call it. You know, every time I upgrade Xcode, I lose my keystrokes. I had put in some to make that extract method at least do its thing. But we're going to call this move paddle, and hopefully it doesn't mind that redundancy. Okay, and yeah, we'll take care of it. Okay, so, well, let's leave it here for a second. So when you call move paddle, it goes down to this case, calls the function, and returns. So let's inline this. Here, we'll replace this, and it's going to go to the next case, so we'll fall through, and we'll replace this, and fall through. Okay. Nobody's calling 41 or anything like that. Okay. Now the move paddle code, that can go away, and I don't need that variable move paddle anymore. Okay. So we can. All right. And again, I think I want to move this down. The reason I like the other way, like it down on the bottom, I kind of want to tell a story top to bottom, and the story here is draw the initial screen, move the paddle twice, and do the rest of the stuff, you know, so I want the details beneath. All right, and that is looking better. Okay, now here, nobody references 41 because the go sub was the only thing that did before, so I can take this out. Okay, and yeah, let's run tests. And if you, let's see, I can take a quick look at our tests. Basically, they're pin down tests. In this one, we just start the game and take the screen fingerprint, which is basically it's a hash of the contents of the screen, and we don't care what value the hash came back with. We just lock it in and say, if you hash the screen after running the game without moving, you will get C6B blah blah blah, and you better get that every time. The second case, we set up the keyboard to simulate moving the paddle as far right as it could, and then took a screenshot at the end of the game. And again, we got 24/6, A5D, and so on. So we've just done a very minimal pin down kind of test. This one forces at least something to happen in the keyboard area. It's probably not an ideal set of tests. I don't know if I were I guess we could run coverage and see what happens, but it's pretty clear to me it's not, there's not a lot going on. So I can pretty much say, this, you can see P equals P minus 1. So it's moving the paddle left. This one moves the paddle right. Okay. Our simulated case did not move the paddle left. So we know this line is actually not being executed, but we'll let it be. All right. So I've got these structural things that test succeeded. Is that correct? Okay, tests are green. Okay. Let's go to the next method. Let's go to move ball. Oops. Oh, this is move ball. Sorry. Okay, it's called in one place. Move ball and returns to 55. Okay. This one's more complicated, so we're going to have to do some work on this one. Is there anything we can do to help? Okay. Well, one thing is these variables, they're what you call ugly. Excuse me. Let's see. SC. Does SC change? Let's see the uses of SC. You know, I thought it was the score. Right. Oh, it makes me wonder if score is decreasing. Okay, yeah. So here, when the character is 161, which is the ball, or a block, sorry. If we see a block, we're going to turn it into a space and decrement the score. So it's more of a golf score kind of thing. So 7 rows of 24, 7 rows of 22. 7 times 2, 140 plus 2, 154. Yeah, so when I got that score of 152 or whatever it was, I just knocked 1 or 2 blocks out. So, okay. Let's see. So SC is score. Let's capture what we know. All right, and let's just do a rename. Oh, that's almost nice. As far as a slice is when you take the places where a value is used or defined and just kind of show all the context of it. That almost makes me think we can do it like that. Okay, let's do this one. B. We'll do a rename. I think, this is basically the ball. Okay, so ball starts here. It pokes stuff there. It changes to X or Y. Pokes. Okay. I think ball is a good name. X and Y seem like good names on their own. We'll lowercase them just to conform. X is the ball position plus the vertical change. Ball moves to X. Yeah, here we're drawing X. That's a little weird. It's kind of a temp there. Okay. Let's see. When we're moving the ball, we start out defining X in there. So any definition of X before there is irrelevant, which tells me I can make this local. I'll do var X and see how that goes. Okay. And then I see X is being used two ways here. Here, it's the start of the screen so it can draw that vertical bars. Here is the start of the positions where we want to start drawing the blocks. All right, so I'm going to do a similar... Well, maybe I can even do some refactoring here. Extract method. Should we call it ceiling? I mean, ceiling and walls seems like the right kind of definition. All right, so let's extract this. I don't know, I could see top. Draw top, draw sides. Yeah, that seems like it's okay. And this is drawing the sides. All right, and this is drawing the blocks. Okay. Top, sides, and blocks. Let's pull that down again. Okay. Now this, I'm the only other references to X were the move ball stuff where it redefined it. So I can make this a variable again, and let's make sure it's still good. Okay. All right, and then here X comes in. We don't change it. I almost could. X never changes, right? So this could be a let. Okay, this one X in out. Let's delete that from the argument because we're not looking at the one that we were past. We're just redefining it. Okay. And this, I can pull this in to the start of each method. Well, it wouldn't do any good here because we redefine it right away, but I can do it here, and it's fine. Okay. So I think this is better. The constants are weird, but 53381 is the start of the screen, top left corner of the screen, and we're writing the top wall. Okay, 128. Let's pull that as a constant. 128 is it's the top wall, or just the top character is 128. Okay, so let's reference that. And I don't think anybody else references 128 anywhere. That's a different 128. Okay. Cool. And this is the left wall, and this is the right wall. 143. Can I extract a constant? No. I never know when Xcode's going to decide it can help me with this, but let's make this the left wall. It's 143. Maybe it's left wall character just to be consistent. And 136 is the right wall character. Okay, any more 143s and 136s? Okay. Progress, and they don't need the arguments if they've got it, so that's irrelevant. And that's irrelevant. That doesn't come in, and that doesn't come in. Okay. Still testing. Okay, what do we got going here? All right, initial screen. Move paddle, fall through. Is anybody referencing 50? $250. Okay. No one references 50. Okay, that succeeded. Let's commit. We extracted drawing methods. I think I missed a commit. Okay, but we got to fall through to case 50 where nobody is doing anything. Okay, so basic go sub move ball 55. Okay, let's see if we can get move 55 in shape to be no go-tos. Okay, because if we have a go-to, we have to call basic go-to and break and all that. It's a mess. Okay, so one thing is, well, let's look at the structure here. If I do 225, oh, well, if I do 215, I fall through to 225. Okay, well, let's see if 215 is referenced anywhere. Only here. Okay, so since I could go to 215, instead I can do this, copy this in. All right, that's the body of 215. Now when it's done, it's supposed to fall through to 225. I could, instead of go to 215, then I could say do the stuff that was at 215 and go to 225. All right, and then this goes away. Now I've got the same code on the end of both branches, so I can move this down so it's outside the if statement because both branches do a go to 225 at the end. All right. So if you think in terms of the graph of the program, I'm sort of copying nodes in where the go-tos are and tracking through and making sure that the path kind of ends in a known place and I can pull every bit of it. If 225, if what was 215 had done something other than 225, we'd have to pull in the stuff there and all that stuff. So it's a safe move what we've done. I don't believe there's an issue. Then we have this 225. Let's see this. 225. Okay, the only reference to 225 is here. It does a break and a case, so really it's just going to end up going to 225 here, so I can get rid of that. All right. And I think this comment is now no longer meaningful. We've folded in the code enough that 225 and all that doesn't matter. So let's drop that. All right, we'll let it test first. All right, well, while that's going, let's look at what happens next. Okay, 230. How do you get to 230? We'll see if anybody GOTOs it or go subs it or anything like that. So the reference to 230, we go there. Okay, so the only reference to 230 is this bit of code, and we fall through. Okay, so we know this is also not doing anything. All right, so let's take this out. All right, now our straight line code ends in either 245 or 235. Let's run tests. So this is why we have those tests. You know, I can argue my way that this is a good move, but the test running is a lot more convincing. Not perfectly convincing, but enough. And then I'm still bugged by this, like this 161s that represent a block, sorry. So let's catch that. Well, we'll push this. We've removed some go-tos. Remove some go-tos and move ball. And the reason this test is slow is there are delays and stuff like that in it. So let's see. Yeah, Q coding. Hey, yeah, so I've got a basic program from like 1982 that simulates the breakout game or plays the breakout game or a clone thereof. And we transliterated it into Swift kind of line by line. We've got this basic support that simulates GOTOs and go subs and stuff like that. And we're trying to kind of push it into a structured program so we can get rid of all the basic stuff. Then we have a true Swift program, and we can work on it as a Swift program. All right. So in this case, we got rid of GOTOs, GOTO in move ball. Yeah. So we did another one that was kind of a swarm game. You had your ship moved back and forth on a line, and asterisks or asteroids came at you. I think this is the only one of the couple I had, although there's books full of old ones, so maybe I'll get interested in doing some more. But and occasionally, like a couple of times, done a little bit of refactoring with assembly, and this reminds me of that. So it's kind of like the easy way, because it's a lot easier to mess with this than try and debug assembler. So it's all right. Okay, let's see. So one thing we noticed is we got these 161s all over the place. What are those? Well, those are block characters. Okay, so we're going to find all those 161s and change them into block character. Hopefully. Yes. All right, another one. And I'm paying a little attention. These peaks and pokes tell me it really is looking for a block character. It's not an accidental match or anything like that. This is drawing it at the initial place, and we're done. All right, and we saw, let's see, the ball. 226 is the ball character. 226. And we'll find any, I don't know if there must be at least one more. Yeah. Okay, poke ball character. I think we've made that comment irrelevant. same thing on this one. 226. Okay. Let's see. So we were back here. I noticed if you do a rename, it slices for you, so we don't have to go running around and finding all the places first. We just try and see if it looks like it's right. So Y is ball plus H. Okay. I don't know what Y is versus X is, but we're just gonna change it. And these Y references all look like they're in the same, doing the same stuff. So I'm okay with that. All right. How about P? Again, I have no idea what this is. Let's see what uses it. And I'm loving this slice. Okay, so P starts out 54119. And when you look at 54118, 54138, okay. Well, actually, we know P is our paddle. Okay, so let's make the substitution. It reads so much nicer. Okay, move paddle. Let's get down there. The move paddle routine down at the bottom. Okay, and it looks a much nicer. Again, I think X is being used as a temp there, but all right. X is 127. Yeah, these constants, they're this horrible keyboard reader. These are screen limits. That's good to know. Okay. Let's see. H. Well, we've got H and V is some sort of horizontal thing and some sort of vertical thing. I don't know what U is at all. So let's take a look there. U equals 7. Okay, it looks like we assign it early on, and the only use of it is the random number thing. So this is it's really a random seed. Okay, so random seed, and let's go find where it's used in 49. 49. Okay, this is initial setup. All right. Okay. And H and V, I mean, they're horizontal and vertical. It's sort of the vector that you're moving in. Yeah. Y equals ball plus H. That just seems odd. Okay. I'm not going to decode it too much at this moment. I'm mostly trying to get the structural stuff, and I'm just doing enough renaming and constants to kind of get me going. So the other one I see is the 32s. Okay. So I think we've gotten rid of the GOTO so that comment doesn't tell us anything. But 32 is very commonly used as a space character. So let's create a constant for that. And again, there may be, now this 32 is a different 32, so we have to watch what we use it for. Okay. 32 here is the screen, well, the way the memory is, it's 24 character lines in a 32 character reserved space. So to go down one line or up one line, you add or subtract 32. All right, so that 32 represents a screen line. These ones with the peaks and pokes, they're definitely space characters. Here, this one, if the x coordinate, x, whatever that is a space, then we move the ball there. So you're moving into an empty square. Poke a space. Yeah, we're seeing that reused X all over the place. Poke is a space. Let's do this right. Okay. Now these on the left side of the poke, that represents the screen stuff. So that's a screen. Paddle 32. That's a space character. So we're removing the paddle. It's 2 characters wide. Same thing here. All right. And paddle is paddle plus 1. Oh, and then, okay, let's get through the 32s first. 32, screen. That's a space. Okay. That's screen distance. All right. And then I saw one more. Where's our move paddle? Okay, so move paddle. Poke 251. Oh, 57088 is keyboard reading. Okay. But that's actually the paddle character. 135. Okay, and we'll create a constants up here. Okay. Let's run tests. All right. While that runs, we're due for a break, so we'll take 2 minutes, maybe 3 minutes, but I'm grab a drink and not much time to do much else. So I'll see you in 2 or 3 minutes, and we'll come back. I guess our tests are still running. We'll let those run and move on. Hey, welcome back. All right, so let's see. Our goal at some level, I guess my goal for today is I want to make sure all the go-tos are out of here. So we've done a bunch. Let's see where we are. Okay, this is the starting one. We'll get that last. 40. All right, so what's going on with 40? Well, we move paddle. We go sub move ball. We do a delay. Interestingly, we delay by score. And then we go around again. Okay, so delay score. The score is decreasing as you go because the score is the number of squares left. So that means the turns are getting faster. All right. So what I see is this go to 40. There's really nothing going on outside of this stuff. Now, if I could get rid of this 55, then I would have nothing else going on. And I could see this is just a while true loop. Okay, it's just go to 40, go to 40, go to 40. Somewhere in our code, we have a break. We pop out. If the ball gets out of range, then print the score and end. Okay, so we've got that going. So I think to make that last change up there, we need to get this move ball in shape. Okay, and to do that, I think we're at a similar place with this go-to. We go to 245 and do some stuff. Otherwise, we go to 235, do some stuff, and fall through to 245. So this is very similar to the other loop. Let's see if there's any 235s. Okay, we just have the 2. Okay, so if I take the code for 235, I'll leave the basic go-to for a second. Okay, I'm copying the code from 235 here. So this is no longer 230. It's not go to not go to 235, but go wherever it went when it was done, which is 245. All right, and now this code is already covered. And we did this process before. We got go to 245 at the end of both branches of if and else. So this code is equivalent. Same thing happens on both branches. You can pull it out of the tail. I I used to have a name for that refactoring. It escapes me now, but it's like pull common code out of tail of conditional or something like that. So that goes to 245. Who else goes to 245? Well, if we look for 245, it's only these two. And again, if you go to 245 and case 245, you can just do a break and you can just get rid of that. Okay. Now, who goes to 250? Okay, well, we do from here. Let's see if anybody else references 250. Okay, that's the only reference to 250. So again, we can fall through and go here. Okay, so we got a bunch of stuff going. We either end or return. Okay, so that may be some trickiness, but I think we can make it work. Okay, let's see if this runs tests. Now, if it does, we're at the position we've got move ball is straight line code. Well, it's got if statements, but no go-tos in or out until the very last line. And we're gonna make a change around that. All right. While that's done. Okay, so we removed GOTO from move ball. All right. Now what's funny here is this GOTO 0 is basically end the program, and this is return. So we were sort of ending or returning to get back, and that's sort of an unstructured exit. What I want to do, and I don't know a name for this refactoring. I mean, this is just a spur of the moment thing in a way. What I want to say is this thing should return a value. Well, we'll start by setting a value, but there should be something to tell you. Did I say you should go to 0 or just do a return? Okay, and so we will. Let's make up a value. Okay, I'm going to call it should quit. Okay, and I'm going to say should quit equals false. Okay, and if you get here, then should quit equals true. Okay, so if I assume you should not quit, but if you do get the circumstances where you should, then I'm going to set the variable to true, and let's just create that up here. Okay, so this is we're still refactoring in the sense that we're trying not to change behavior, but we're definitely taking a different tack on things. Okay, so now when you call move ball, the end result is you either have should quit false, should be a var. All right, when you get to the bottom, should quit is either false or true. It's a Boolean, and we initialized it, so it's the consequence of the state of things at the end here. All right, and now if should quit, then you want to do a basic go to 0. I'm going to pull this. Well, basically, I'm going to pull this out. Okay. And like I said, this is a non-standard thing. Let me justify it first, wimpy as justification as that is. Since GOTO 0 is ending the program, this is dead code. All right. And so as long as, theoretically it's dead, I could pull it out. But I want to do my return. Okay, so I'm going to pull it out of here. Okay, and when I return, all right, I want to make sure that I should either go to 0 or just do nothing. Okay, so I'm changing the way this ends. Instead of go to 0, I'm just going to say return, but then the caller has to take responsibility for should quit. Okay, so the go sub here, this is what immediately follows the go sub. Now I'm going to say if should quit, we're going to do something, else we're going to do this. Okay, so if you should quit, then we're going to do basic.goTo0. All right. And otherwise, we're doing the stuff we would normally do when we get back. Okay, and this is probably the most complicated move. It's certainly the most complicated move we've made so far. Most of the rest have been standard refactorings, either done by Xcode or in the case of renames and extract methods done by Xcode, and some extract constants done manually. That's pretty much it. The go-tos were sort of a complicated thing. Okay, but our test should pass. That's the intent. And it should terminate, more to the point, because that's what we're really trying to get going here. And like many acceptance tests, they run slowly, but okay, it does return. That's the big thing. Because if we messed it up, we would forget to do the go to 0 and it would never return. All right, so I'm going to take this out. This, I can take out the else clause because it's now empty. Okay, and that's good. Let's see what's up here. Okay. All right, so if we should quit, we go to 0. We're forcing our way out. Else, we go back to 40 and repeat. 40's not so far away anymore. Okay. Let's see. So we did basic go sub move ball 55. Now we can extract our method. And as I extract, notice there's nothing, no go-tos in or out. Okay. Even down through this stuff. All right, so this, I'm going to extract method. This is move ball. I'll call it move ball 2 for a moment. Okay, just to avoid the error we got last time. All right, now move ball 2, the only place that's called is here. Okay, so go sub move ball 2, return to 55. That's really the same as move ball 2. Okay, and this goes away. All right, so now move ball 2 and then go to 55 can be a fall through. All right, nobody should be referencing this anymore. And in fact, nobody should be referencing that move ball variable anymore. Okay, and given that, where's move ball? I can rename this to move ball. And I can move it down where I want it. There's move ball. Let's take out some junk. Okay. Alrighty, so we'll run tests. right, test passed. Now we don't need this 55 thing anymore. Move ball is its own thing. We're following through case 55, and that's that. All right, so our top, we start with case 10. We've done a lot. Okay, we start with case 10. You fall through to 40, or you go to 40, and that's the only. Well, I guess this is go to 0 is a go to too, but in effect, we've done most of the stuff. Okay, and the only calls to basic are these two. All right, and let's see. So we want to change this. All right, so what I'm going to do, boy, I'm going to say go to 40. I'm going to make this while true do stuff. Okay. Now, if we should quit, we have to do something. Well, we're going to break. Okay. We're going to break. I'm hoping that breaks out of the loop. Okay. Let's indent. Okay. Boy, do I wish that would leave you where you started. Okay. So now, fall through to while true, move paddle. If we should quit, we say basic go to 0, and then we break. And actually, since this happens, I can move this down, because the only way you get out of this while true loop is this break. Okay. And this we don't need anymore because we did while true. Okay. Run our tests. Now what I see is, yes, it's structured, but it's kind of a weird structure. And what I'm tempted to do, so this delay, it happens after each thing. I would love to make this not care. And I'm recognizing that's a functional change, so I'm changing hats if I do that for sure. Okay, that succeeded. So let's see, we turn main loop into while true. All right. Well, okay, one thing is, if should quit break, that jumps out to here. We don't need an else clause on this. It's just going to happen. And it won't happen in the should quit case because we just broke out, so that's okay. All right, so now I'm looking like half the stuff is... well... It's a loop and a half kind of situation, and I don't know if how I want to deal with that. One thing I could do, and it's going to change the game, but it won't show up in our tests, so it's kind of annoying. But I could move this up here and say the top of the loop, you're just going to delay a little bit. And what the effect would be is the first time through, you get an extra delay. Okay. Now, I don't know if I care about that. Let's see what else we can do first. Let's finish cleaning up those go-tos. We have one case, fall through, case 40, nothing there. Okay. So we're saying set up a bunch of stuff print some lines, draw the initial screen, move paddle twice, move the ball once. If you should quit, break, otherwise delay and go back around. And basic go to 0. All right, now I want to make the biggest change. Okay, so instead of basic.run, I want to just call blocked. So I'm claiming, okay, it's a change. I'm claiming I can delete this stuff. All right. And go to 0 says just make an end of it. All right, which exiting routine will do that. All right. So I'm claiming that we have this blocked function that can do that. And if I wanted to, I could call blocked of 10 instead of going to basic. Basic's mechanism is take the line number and call the switch statement with that line number in a loop until line equals 0. All right. This is the move I want to make to get from pure basic to pure Swift. So it's a good point. I mean, it's a good accomplishment. Oh, and I'm just noticing my my screen there. We haven't kept our to-dos up to date. So while that's going, let's go over here and do this. Okay, pin end test, start no moves. We did that last time. And we also did a pin down test start and move hard right. Okay, today we've been doing this, convert code to idiomatic Swift. All right, and that was remove GOTO, make call functions, and that. Okay, so blocked 2105. Whoops, 08, 09, 8. Here I am in August, still getting the year wrong. Does not bode well for 2022. All right, so we're doing this. That's kind of the high level task. And we did this. Maybe turn that into a plus. And we did this. And we also did eliminate all calls to basic support. Okay. Well, that's kind of what we're doing. Let's call that what we're doing. Okay. Let's see. We've run our tests. Let's commit. Okay, remove remaining go-tos and make the call our method directly. No basic support. I suppose I should capitalize that because we're talking about the programming language. All right, let's run the game and then do a little more cleanup and see where we are. All right. Drawing our lines, draw our sidewalls, draw our blocks. We'll move over towards the right. Bounced out of the way. 153. Okay, so yeah, there are 154 blocks. What do we want to happen? That's the tricky one. All right, let's do cleanups first. Okay. Now, we got rid of that. We commented out that. Let's look for basic. Basic. And that. And we don't reference it anymore. Okay, so we can take this out and this out. Basically also imports the environment. We can't get rid of the environment. All right. Okay, we don't need this anymore. What else can we do? Well, I'm inclined... Let's see. We're making this more current, so I'm moving it towards a Swift-only environment. Poke 530 does nothing, so let's take those out. It turns Control-C on or off in the basic, and we don't really need that concept in our code. Okay, 57088, that's the keyboard stuff, and my goodness, this is ugly, ugly, ugly. Okay, so it's doing some keyboard reading and then deciding what to do about it. The change I want to make is a bigger change than we're used to. All right, I don't know what's the best one to tackle. So there are places where I'm kind of happy, and there's places where I'm not. I'm a little confused about H and V. Let's go back to the use of those. Okay, so H. I would have thought H is horizontal. So H and V, these are horizontal and vertical distances. And H should be... Basically, H's value starts 0, becomes 1, can become 0, 1, minus 1, 0, or 1, and it can be flipped, so 0 to 0, minus 1 to 1, vice versa. Okay, so it's got a very restricted range. V... Okay, so let's see what Y is being used for. Adding ball plus H, that's moving the ball left or right. Why that's called Y, that does not make sense to me. Okay, let's cancel this. Let's see what Y is doing. We'll do the rename thing and then we'll look around more. Okay, so we move the ball position. If you peek at Y and it's a space character, then you move the ball there. If you peek at it and it's a block character, you poke the space character there and decrement the score. Okay. It always... Well, this all seems to be happening in a very restricted place. I think Y is it's not X and Y as meaning X and Y coordinates or anything like that. I think Y is just a little temp character. It's like the next ball position. Okay, and here if it's a space we move it, and if it's a block we don't do it. So what we're going to do is go back and go through some data flow on it. All right, so let's find Y. And references to Y was like 154 is down here. Okay, so we have this variable Y. It only comes through here. Well, it always comes through here. And okay, in this path, there's no other references to y. Okay, so the only way y gets initialized is right here. All right, let's see if we can make a variable out of it. Actually, I think we can make a let out of it. Yeah. We set the ball moving left or right one character, and then we see if that is occupied or not occupied. If it's a space, we move the ball there. If it's not a space, okay, if it's not a space, we either hit a sidewall, top wall, or a block. If it turns out it was a block, well, let's see. It's apparently not a top. We're only moving left and right with H. Okay, so it's never going to be the top. It's either going to be a sidewall, left or right, or a block. Okay. And if it's a block, we're going to put a space there. Okay, so in either case, well, no, it's not quite right. This is the new ball position. All right, let's make sure this runs while I talk and think out loud. Okay, so y is sort of the tentative position. If we get a space character, then we can just move there. If we don't get a space, then we're going to bounce sideways. It could be a block. It could be a wall. If it turned out it was a block, so if it's a wall, that's easy. We're going left. We hit the left wall. We turn around. So the next time we hit the right, we head to the right. If it's a block, we're still going to flip, but we're going to put a space there and go on. Okay. Now I'm confused by X here as well. I think the logic is the same. Why X is ball plus V? I mean, the names are backwards. This is really more focused on a vertical move. Okay, so if we add or subtract a line, do we hit a space? If we do, it's fine, just go there. If not, we should bounce vertically. So if we hit the top wall, go down. If we hit the top of a brick or block, go up. And if we hit the bottom of a block, go down. Okay, so either way, you're flipping. Okay, and the X is not going to get used again after, because this one here, this is the keyboard stuff. All right. So I'm going to say this is a let as well. We don't change X after this. All right, well, let's run tests. All right, so we got these two temps. I think this code okay, we're erasing the ball. This code is moving the ball vertically. And this code is move ball horizontally. Okay. And I almost think this is better. Okay. Erase the ball, move it vertically, move it horizontally, and draw the ball. All right, and then we make some decisions about what the heck happened. Okay, I think we can make this go. All right. Move these methods down. All right. Let's see. I think we'll run the tests again. So this is a good time for a break. Again, 2 or 3 minutes. We've changed the way these constants work with the x and y, making them local variables, and we'll deal with the consequences when we get back. So I'll see you in 2 or 3 minutes. Bye. All right, welcome back. So we've improved our move ball method. It's starting to sound realistic to me. Put a space where the ball is. Now there's a little bit of weirdness there, but okay, we put a space where the ball is, move it vertically and horizontally, put the ball back. I guess the ball is always going to move somewhere. Okay. This variable y. Let's see who else uses y. The easiest way to do that is this. Okay, because if it were being used by anything, it would blow up. All right. Now, let's see these x's. Okay, these are local. 53381. Let's go look at our pictures. 53381 is the top left corner of the screen. Okay, so it gets set, it never changes. Let's make this a constant. And I think we'll call it screen top left corner. Is that okay? Let's find all the 53381s. Okay, so this is screen top left corner. All right, but notice x is set and it's never changed, so I could inline it. And I don't need the variable. All right, same thing here. Set 53381, I can inline it. All right, and I don't need the variable. 53381 referenced anywhere? Okay. Now the next thing I saw with that, where's screen top left corner? Okay, this plus y, that makes sense to me. This seems backwards, like I should just say, it makes more sense to me to say this plus that than vice versa. Okay, so screen top left corner plus that plus 23 plus 32 times y plus 23. Okay, that makes more sense to me. Okay. All right. Let's see. So that was, well, it was several uses of x. This 53541, let's go look at that. 53541 is the screen, and this is the block row start, block start maybe. Okay, 53541 is screen block start. Pull this. Screen block start equals that. Okay. And okay, so this screen block start, again, it's a let variable. I think it makes sense to have it at the front. Screen block start plus that. Okay. It's never used now. All right. So we're getting things more in terms of screen. Now here we got local variables y and z. Y is really the row and z is the column. Row. Column. Okay, for each row, we're doing 32 times the row plus the column and putting the block character there. That's starting to sound good. 32, this is the other 32, is the, I would say line distance. Maybe screen line distance. Screen line distance equals 32. Okay, and again, back to our screen. So if you notice from any one of these, let's take 45 to 77. If you add 32, 45 plus 32 is 77. So that tells us these lines are 32 characters apart, even though they're only 24 wide, because there are 4 guard characters or unused screen, non-visible screen characters on each side. Okay, so let's find our 32s. That is an example of that. Okay, so that's screen line distance. Screen line distance. No. Screen line distance. Distance. Okay, everybody was at 32 was either a space or a screen line distance. Okay. Run tests. I'm saving the keyboard stuff. We'll see. Maybe we'll finish that today. All right. Well, that's done. Okay. So we extracted constants for screen positions and distance. I'm still bugged by this. What I want to do is I want to make this stuff happen after we exit. So if should quit is true, we exit the loop and I want to do these things. So I'm going to comment them out. And again, this is not a look it up in Martin Fowler's book kind of refactoring. I'm doing this knowing that the code that exits with should quit true, code that happens after that can move up here after the true because it broke out here, so now I can do the code here. All right. And I know of no formal written up refactoring that justifies that. The way I could justify it, I could inline code, I could, extract things around and stuff like that. But, you know, I'm kind of using a bit of intuition, but I'm fully believing it's legit. It's saying if you exit, if you do should quit, you'll come out. You're not doing anything else except exiting the loop and falling through. Well, before you fall through, do the stuff that happens at the end of the game. Okay, let's do that. Now, should quit false starts false. It's true if it's greater than 54141. Well, that's the same as this. Okay. And this code is replaced. Okay. And the only thing I'd like to do there, should quit. Maybe it's game over. I'd like to have move ball return that value. Okay. And so in effect, I'm doing the same kind of move. I'm saying, if you return a Boolean, oh boy, game over. Basically, maybe it should be an enum. I hate returning Booleans because you get the Boolean. It's like false, true. What am I supposed to do? Let's start with a Boolean. Okay, that succeeded. So we're going to start with a Boolean. We're going to return a Boolean, and if it's true, you should quit. All right, so let's return should quit. Bool. Okay. Now the caller is up here. All right. Let should quit equal move ball. Okay, so again, I'm moving something that was in there out. All right. If should quit break. All right, let's run the test, and then we'll clean up further. All right, so what I see is should quit is set and returned. Nobody's looking at the return, the variable itself. They're looking at the result value. So I'm gonna change that to use this. So in effect, I'm inlining it. Okay, but it's not a true inline because this is a global variable or class level variable, but we're not going to reference it anymore. Okay. And where's the call? Should quit. Okay. I'm going to rename this variable game over. Okay. And I don't think anybody's using should quit anymore. Right. Okay. Oh, yeah, okay. Let's get that right first. All right. So we moved final code after the loop. We made move ball return true if game is over. Alrighty. Okay. Move the paddle twice, move the ball, game over break, do some stuff, delay some score. Less and less every time through. Let's see. Can I do anything else on that? Well, okay. Well, ball is coming in implicitly to this thing. I can move this out again. All right, let's try that. Okay, so instead of looking at the return value, let's look at the ball, because the return value basically boils down to the ball. Okay. So in here, game over. Well, if we did move ball, let's see, did I copy that? Yeah. Okay, if we just call this move ball and then we did this, we'd have a return value, but we'd be ignoring it. I'm surprised it doesn't complain. Okay. But that tells me we don't need it at this point. Okay, so let's take the return off. There's a story of Oscar Wilde that someone asked him how it was going, and I had a hard morning. I put a comma in, and then in the afternoon, and how was the afternoon? She asks, and it was equally bad. I took it back out. We're doing the same thing here. We made it return the value, but now we're moving that outside. And I think we probably could have done that originally if I'd seen it. But now move the ball just moves the ball, and then we make some decisions. If it's over break, okay, I want to make a change that is it has an effect. Okay. And I mentioned it before. I think what I want to do is I want to say before the first move, we're even going to delay a little bit there. All right, so we'll draw the screen, delay, and then move the paddles. Okay, so I'm saying I'm changing the way the game runs. I think the tests won't care because the time delay, we don't check anything about the time. Okay, and we'll run the game and make sure the gameplay is plausible. If we really had to, and maybe I should do it that way. Okay, let's do it the proper way. Let me undo this. Okay, what I'm saying is delay happens every time through the loop after the first time. Okay. And the strict way to do this would be, let's have a first time variable. Var first time equals true. If it's not the first time, we'll do the thing and we'll tell it no. Oh, let's see. If it is the first time, well, let's do it fully properly. If it is the first time, if it's not the first time, okay. First time starts true. It's the first time through the loop we do not do a delay, but we set this up so the next time through the loop first time is false and we will do a delay. Okay. Now, I think by changing this loop and a half thing, we're helping something. Okay. Let's make sure that runs. These old kind of restructuring things, they used to be kind of significant, like Fortran and Basic that had the GOTOs and all that stuff. You end up with these loop and a halves and stuff like that, and you got to decide if there's a way to kind of structure it over. All right. That passed. Okay, so the next trick is the ball starts at 54090. That is less than 54141. All right, so my loop in effect, the first time through, is ball greater than 541? No, it's not. Okay. If I run this loop and then I check if the ball is greater than 54141, break. Okay, that's all that's happening there. In effect, that's the sort of the same as saying while the ball is less than or equal to 54141. Okay, so while not, I'll do it the slow way because I'm trying to be careful. Okay, so while the ball is not greater than 54141, then we're going to do our loop, and if the ball is greater than 54141, so the first time through we know we're okay, so we'll ignore that. We go through, we do the stuff, we come down here. If it's greater than 54141, we should be over. Well, if it's not greater than 54141, we're going to continue. Otherwise, we should be over. So I'm using kind of the definition of a while loop to justify this change. And now I'm going to flip the condition. Okay, not greater is less than or equal. Okay, so while the ball is 54141 or less, run through the loop. Move the paddle twice, move the ball. Delay, move the paddle twice, move the ball. And this is looking a lot more structured than the original. All right. That constant sticks out. Like, what random thing is that? And we can find it. 54141 less than or equal to 54141. Well, that's that bottom right corner. Okay, so we can call that screen bottom right corner. Is 54141 corner. Bottom right corner is that. Okay. I probably should put these in a somewhat ascending order. Okay. Now. Okay, while the ball is less than or equal to the screen bottom right corner. Okay. We'd have to convince ourselves it stays in range on the left side. It's got to be greater than or equal to the screen top right corner. But if it is, if it hasn't bounced off the screen just yet, move the paddle, move the ball, and repeat. Well, delay, move the paddle, move the ball, and repeat. If you got past the bottom right corner, you bounced off the bottom of the screen. And we're going to print the score. Okay, we're exiting and printing the score. All right, that's much better. This stuff is all a little ugly, but that's progress. Now, let's run the test. Make sure that's all okay. and we restructured the main loop, I guess would be the thing to say. But I find that pretty encouraging to read. I mean, the ball is less than or equal to the bottom screen corner. I'd have to convince myself it's in the range of the top. And I probably could add that, ball is in screen range. That would be convincing. If it's out of screen range, you're bouncing around through memory somewhere, something went wrong. Okay, so imagine we forgot to draw our top line, okay, and the ball heads up, and it heads up one extra. Now it's less than the start of our screen. So it's, it's hard to know we would catch that. And at some point, like way back when, I tried writing I did write a breakout style game, and I had exactly that problem. I did something wrong on how I checked for the top position, and the ball would go shooting around past it. And at that point, it's moving whatever direction it was going through memory, throwing random characters and random stuff, and little weird diagonal lines would appear on the screen or whatever, and it just it's pretty ugly. All right, succeeded. Good. So we restructured main loop from while true to let's just say restructured the main loop. Leave it at that. All right. I still see some constants. This is a decision about the number of block rows. This is related to the screen width. We haven't dealt with the keyboard. Okay, and I don't know, the keyboard maybe next. Maybe we should get those constants out of there. We got H and V. H is horizontal, V is vertical. Let's tackle that. Rename 0, 1, 0, 1 plus or minus 1. Used as 0, 1, 0 plus or minus 1. Okay, so I'm going to call this horizontal. And this one, let's make sure it still is vertical. Vertical equals minus screen line distance. Yeah, that seems true. We don't want these. Okay. That quoted V has nothing to do with this. All right, this is vertical. Paddle, horizontal, vertical. Okay, that's one thing. Just random seed. And it gets assigned to 7 at the start and never changes. So let's make it a let. Okay, score 154. Well, that's kind of arbitrary. Ball 54090. This is screen ball start position. Well, let's get the paddle in there. Let screen paddle start equal. All right. Look for any more of these. Okay. Screen ball start. Block, the ball starts beneath them. .4090. Anybody using that? Nope. Okay. looking for arbitrary screen related things. Okay, 54118. If the paddle is greater than 54118, we move left. So if it's equal to 54118, that's as far left as we go. Okay, so this is the paddle, screen paddle left, screen paddle minimum. I'm trying to get these somewhat related to each other. Okay, that's true screen stuff. Ball start, block start, ball start, paddle minimum. Let's find more 54118s. Okay, let's go down to paddle min. Okay, so 54138. If it's 54137, we will let you add 1, so it'll be 54138. So this is paddle, screen paddle max. Okay. Now this one, I would love to just say screen paddle min plus 1. Can I do that? No. All right, let's go find this one, and let's rephrase it as screen paddle min plus 1. You should get a little red mark somewhere. Initial, okay. Screen paddle start, that's really screen paddle min plus 1. Okay. Those are good. Let's see. This Y here is a column. We'll rename that to column. This Y is, it's really a row. It's this thing of reusing these variables, you know. Okay. Screen line distance plus times row, that's a good thing. Row column. All right, we'll run tests. We just did a bunch of renames, basically. And constants, okay. All right, well, while that runs, thanks for joining me today. Let you know about a couple other things. Just XP123 is my main website. I normally publish articles on Wednesday, and this Wednesday I anticipate something around refactoring when you wrap primitives and you have to kind of change a bunch of places, kind of some strategies around that. You can sign up for the email list if you like. I'll send you a free ebook and links to the articles each week. All right. Next time will be Friday. I guess that is the 13th. Is that what we have next week? 1 to 3 p.m. Eastern time. And what we have left to do is mostly around the keyboard. So this we created constants, rename. The keyboard stuff is still looking really ugly. It's got totally arbitrary numbers in it, and I want to make this much more Well, I want to make it more understandable. So we'll tackle that. And I think that will do it for the body of this. Then we can work on some other transformations. Well, we got some screen constants sticking around still. 22, 23, 24. They're all related to the screen width. Okay, so we'll pick up there next time. And thanks for joining, and I hope to see you again. Bye-bye.